Hello, in this tutorial we will go over checks for normality, or we'll answer the question, how do we know that the data that we are using follows a normal distribution? There are 4 checks for normality, and it's important to note that if any of these 4 checks are violated, then our data is not normal. So our first check is to calculate the Pearsonian skewness index with the calculation that's on the screen. If it is normal, our Pearsonian skewness index should equal about 0. Our second check is to inspect the shape of a data if we place it into a stem plot or into a frequency graph. And if it's normal, the shape of our graph should look like a bell. Our third check is to use the 68, 95, and 99.7 rule. And if our data is normal, then 68% of the data should fall within plus or minus 1 standard deviation of the mean. 95% of the data should be within 2 standard deviations of the mean, and 99.7% of the data should be within about 3 standard deviations of the mean. And our final check is to create a normal quantile plot. So our question is, what is that plot? It's a plot where we have the observed values as we've measured it, or as we've collected the data, or as we've converted it to a z-score. We're going to put those on our x-axis. And then on our y-axis, we put the theoretical z-scores, assuming that our data is normal. And if it's normal, the plot of our observed values and our theoretical z-scores should plot into a straight line. So we'll calculate and show how we can develop this through Excel. So to develop our normal quantile plot, I've taken the data that's on page 136 of your student course pack, and I've placed it in this spreadsheet. I've placed it and organized the data into an ordered array. And also, I've added an additional column which numbers each of these observations. To calculate our cumulative proportion, we're going to take that observation number and divide it by the total of observations that are there. The result is that this value tells us the proportion of observations that are at or below the observed temperature value. So in other words, 0.033 of our observations lie at or below 10.3 degrees. We can copy this formula all the way to the bottom of our column. And you'll see that 1.0, the total amount of the observations lie at or below 34 degrees. We're going to calculate our theoretical z-score by using the Excel function normsinv. And we're going to put the probability being the cumulative proportion inside the brackets. This should calculate our theoretical z-score, and we can copy this to the bottom of our column. At the bottom here, we have the num in the cell, which means that it's an infinite number, and we won't include that in our normal quantile plot. We are going to insert a scatter plot, and we're going to remove this data that's here, and we're going to add in our x values our observed temperature, with the exception of the last row, and for our y values, the theoretical z-score if normal, with the exception of that last row. Click OK and OK, and we've developed our normal quantile plot. We don't see the line, the straight line that we would expect if our data followed a normal distribution. Instead, we have data where there are bunches and also gaps in our line. This indicates to us that our data does not follow a normal distribution. This plot should be very similar to the one that you see on page 136. And so through this tutorial, we've covered all the different checks for normality that we should look for in our data, and we've also covered how to create a normal quantile plot through Excel.